In this video, I'm going to be talking about ray diagrams with lenses. So in a separate video, I discussed ray diagrams with mirrors, which tends to be, in my opinion, slightly more complicated than lenses. With lenses, you can basically follow two rules, which are sending a light ray through the center of the lens or sending a light ray straight to the lens and then bending it through the focus in some way. So on the top row over here, we have three converging lenses. You could either call them a converging lens or you can call them a convex lens. And on the bottom here, we have two diverging lenses, or you can call them concave lenses. So as I said earlier, with all of your lens diagrams, you can draw a light ray through the center of the lens, or you can also draw it straight into the lens and then do some sort of version of bending it through a focus. So on our top here, we have three convex lenses, and I'm going to start off drawing a diagram with the object outside of the focus, one on the focus, and then one inside of the focus to see what type of images we produce. All right, so for all of our top diagrams, we have all of our light rays converging towards the center. So a basic rule of thumb you can use for lenses is that the light rays always bend towards the thickest part of the lens. So for all of our convex lenses or converging lenses, it pulls the light rays towards the center. So as I said, we can always shoot a light ray right through the center of the lens. That's kind of like our free light ray for our convex lenses and also our concave lenses. So that's kind of your free one. You can use that on each one of them. And then for all the rest of them, you send one straight and then through the focus. So I sent one straight and then converge it down through the focus. And we have an image that is real. Inverted. And for this one in particular, the size is going to be exactly the same, which is usually not the case, but this one is exactly double the focal point. So it ends up being exactly the same size as the actual object itself. Okay, it's considered a real image because it's on the other side of the lens. So as opposed to mirrors, mirrors have real images that are on the same side of the object because the light reflects back onto the same side of the object, as opposed to lenses where they're transparent and then the light actually goes through them. So this is the real side, and then this would be the virtual side. This is considered inverted because it's obviously upside down, and then based on the size of the image compared to the object, you would call it smaller, the same, or larger. In our second case, it's a very unique case where the object is directly on the focal point. So if we send our light ray through the middle, and then the other one straight and bend it through the focus, what happens is these light rays are parallel, so there are no images produced. For the final one, we have our image inside of the focal point. And what happens here is we send one through the center of the lens as we did with the other ones, and another one straight and through the focus. And then if you can tell, they're not exactly parallel. This one is kind of diverging away from this line a little bit. So what you do with this scenario is similar to what you do with any type of lens diagram. If you have two light rays that are not converging on each other, then what you do is you always dot them back to see if you have a virtual image. So if I go ahead and dot this one back, and dot this one back, we do have an intersection back here. And this image would be considered virtual. Because as I said before, the light that would reflect the object goes through the lens. So this is the real side, and then this is the virtual side. Our image is upright, and it is clearly larger. Okay, so this is basically how a magnifying glass works. If you have something within the focal length of the lens, then it's going to enlarge it. And if you look at something far away, it's going to look inverted. All right, now for our final diagrams, we're going to do a concave lens diagram. Now, all these are pretty much the same. I'm going to draw two so you can see how similar or different they are. But for most of the concave lens diagrams, they're going to be pretty similar. All right, so if you take a look at both of the concave lens diagrams, they look fairly similar, as in they have one light ray going right through the center, just as we did with our other ones, and then we have one that goes straight. And then this version of straight through the focus is a little bit different. Remember, it's a diverging lens, and also, as I said earlier, a lens always makes light rays bend towards the thickest portion of the lens. The thickest portions are always the outer portions for a concave lens. So they're basically bending away from the center, the exact opposite of a convex lens. So what I did was I drew a light ray right through the center for both of them. And then for the second one, I did the same thing. Instead of sending it straight through the focus, I did straight and aligned it with the focus so I could see which angle to diverge it on. So same thing with this one over here. I aligned it with the focus. Okay, now because these two are diverging from each other, just like we did over here, we always dot it back to see if we have a virtual image. And I did actually already dot this one back. And if you dot this one back, you're basically tracing the same line. So for both of them, you get a similar image. Okay, both of them are virtual because they're on the same side as the object. They are upright, and they are definitely smaller. All right, so to sum up everything we did for these ray diagrams, for all 5 of these different diagrams, the easiest one to remember is the light ray that you shoot right through the center of the lens. And then for our converging or convex lenses, we sent the light ray straight into the lens and bent it through the focus for all 3 of them. And based on what happens as a result, you may have to take some steps after that. This one we had our intersecting point, so we already knew where our image was. Right on the focus is our special scenario that has no image. And then the very last one over here inside the focus follows our rule. If the 2 lines do not intersect, you dot them back to see if there's a virtual image produced. Okay, for our second ones, we shot that light right through the center, and we did a version of straight and through the focus. but we just aligned it with the focus so we knew how to diverge that line, and these two clearly do not intersect. So what we did is we dotted them back, and we had a virtual, upright, and smaller image for both of them. I hope that was helpful in helping you understand ray diagrams for lenses. Thank you for watching and listening.